I'm CK. Tonight we're going to do the fourth in Erica Synths educational series. This one is their sequencer. I've done their VCO, their envelope generator, and their dual VCA. And this is the fourth, and I think it's the last one. However, I was wrong about the last one the last time, so we'll see. Hope you enjoy the video. Here's the box. Got this from thonk.co.uk. And as I said, this is the fourth. It looks like they're back-ordered. Actually, their website says pre-order available in June of 22, and it's actually May of 22, and I've already got it. So I don't know what that's about. But again, this is the fourth. Let's take a look at the front panel and circuit board, which tell us a lot about any kit. So, get the box ready for recycling. Let's see, we've got step count 3, 4, 5, rate, gate 1, gate 2, gate 3, gate 4, gate 5, step 1 level, step 2 level, step 3 level, step 4 level, step 5 level, clock in, clock out, reset, gate out, CV out, and CV range. So that may be a switch, because that says 5 volt and 2.5 volt. So it looks like a relatively straightforward sequencer, nothing too fancy, which fits with the whole EDU series. Oh, that's not quite perfect. So that's the front panel. Let's take a look at the circuit board. And the circuit board is, you know, it's funny, it's this dark black, which is like a surface mount circuit board, but this is all through hole, which is good for an educational one. And as you may be able to tell, all the components have their values marked on the board, which is nice, so you don't technically need a bill of materials. Now, one thing I'm seeing quite a bit of here and here and here and here and here and here are stand-up resistors. In other words, resistors that are mounted vertically instead of flat on the board. As I've said in the past in other videos, I don't particularly care for stand-up resistors. I know they can save space and they're good for making changes late in design, but I think they're a little bit error prone. So that's the circuitry side, and this is the control side. Okay, so the step count looks like a switch. The gates are switches. Step level should be pots, and then jacks for the in and out. So that's what we've got on the board, all through hole plated. The boards are really good quality. Let's take a look in the bag. A whole bunch of diodes, 4148s. Whole bunch of resistors. I think those are, what, 10K? Transistors. Bunch more resistors. One resistor that got its poor little leads bent in shipping. Poor thing. Some more diodes, more resistor, resistors, diodes. Got a little piece of paper in here to tell us something. It says transistor BC54-8C, possible replacement 54-7C. Okay. I don't know which one we have, but whichever one we get is fine with us. one IC. This is a Texas Instruments CD 4017BE. I think that's a decade counter. I could be wrong, I'll double check that. And this is a TL074CN, again from Texas Instrument. That's an op amp. Another little resistor. And I'm going to put these other things over in this other bin. Except I'll move that resistor over here. And here we've got a little bitty cap, the switches, some electrolytics, some LEDs, foil cap. Pretty straightforward, nothing too unusual in there. Then in the final bag is all the pots, power connector, and the jacks. Now, so that's the parts. One thing I do want to highlight, oh, I'm going to complain about this again, because I ran into this when I set up a bunch of the units in a separate rack. They're using a ribbon cable which doesn't have a solid stripe for the red or negative 12 volt line. It's got this red dashing, and it's really hard to see when you're putting something in the rack and you're connecting it to power. If you have to go behind the rack or it's a little dark, this is really hard to see. I wish they would use the solid striping that is typically on a Euro rack module. One second. So here's a typical one, and here's theirs, and as you can see, this red stripe is very, very easy to see, very easy to discern in a studio, in a darkened studio, in the back of a rack, in a club, whatever. This one you can hardly see. Again, I wish they would make a better one. Now, one of the most important things about this series is not really the module itself, it's the user manual. The user manual is very comprehensive. It's more than just putting together the kit. It's showing you how to, if you want, breadboard the whole thing out before you start soldering. Then it goes into sequencer basics. Talks about the, and that's what I pointed out before, this is the CD4017, it's a decade counter chip. And they go very much in depth, very practical introduction to electronics, and electronics in particular targeted to music. So I really, again, I'm going to say this again, I've said it in each one of the other three, even if you don't buy this kit, and I recommend you do, I forget exactly how much it cost in US dollars, it was 65 British pounds, which is relatively inexpensive. But even if you don't do that, go to their website and download these guides. If you're just starting out, you're going to learn a ton. Even if you're very familiar with sequencers, with electronics in general, it's a good review and you might learn something new from it. And again, it's very comprehensive. You're getting, for the price you're paying for the module, getting access to this would be worth it all by itself, and you don't actually have to pay for this. So very good user and build guide. Go get this. And now, since we've got all the parts out and we've looked at the build guide, I'm going to power up the soldering iron and we'll get this thing going. Alright, we're going to start with all the diodes, the two 10 ohm resistors, and the two other diodes. Let me make sure I've got the... So these are the 4148 diodes, which you'll see a lot. Let's see, 2, 4, 6, 8, 10, 12, 14, 15 of them. That's a lot. On the board, you can find each of them, of course, and you'll see the stripe on the symbol on the circuit board. That's where you put the black stripe on the glass of the diode. So let's put one on to start, just so I can give you... Let me pull this tape off all this end. Because I always like to do one first. When you haven't worked a lot with a company, you don't know what software they're making or using to make their circuit board layout, so you don't know how far to bend the pins. So I like to just take one to start and see how it goes in, see if I have to get the leads tight up against the component body or further away. And it looks like this one, this board layout software for the 4148s, you have to leave a little bit extra on the side. So I'm going to put all 15 of these on, and as is typical when I do this, now that I've put one diode on, there's not a lot to talk about for the others, so I'm going to go into fast replay, and you'll just watch the diodes fly onto the board. All the diodes and the two 10 ohm resistors are on. Next thing we're going to do is we're going to put the IC sockets on. Rectangular style socket pins. I find them easier to work with and a little more secure once the chip is in. So set the socket in its appropriate holes. Rest it on, in this case, my ring finger on the back, and I'm going to solder one leg. Let the solder cool. Now take a look, make sure it's all flat and flush to the surface of the board. And it's a little bit up, so I'm going to push on it, reheat that solder, and there, now it's nice and flush and snug. So I'm going to do the rest of the pins. Now we're going to do all the ceramic caps, and I think they're all the same value. Oh no, that's one. Those are 104s. That's 0.0 microfarad. 0.1 microfarad, that is. No, they do seem to be all 104s. I thought I saw a 2 in here, but I didn't. They're all 104s except for this one, which is a 102. So we'll find all these. All the 0.1 microfarad caps go in first, the 104s. Oh, I filled in a hole. I went a little too enthusiastic on my soldering of that IC socket, and I filled in a hole. So let me get that all heated up. There we go, cleaned that up. Now this all looks good except for this one lead is really close to that mounting pin for that jack, so you want to make sure you get that flush cut as close to the board as you can so you don't get any interference when you're putting those on. Okay, now we're going to do all the stand-up resistors. We'll do all these 100K resistors first, and I'll show you why I'm not a big fan. So they're great for saving space. I'm not going to disagree with that at all. So you take your resistor, you fold one lead over. I generally try and get the first value stripe at the bend. You don't have to do that, but I like to just to have it. Then this one goes here, and you put it in like so. Now, what I don't like about them, let me put the next one is also, next to it is also 100K. So I'll put that in there. See, I don't like having the leads up where they can interfere with something. They probably won't, but they could. The other thing is they can lean over. They can, if you're not careful, see, if I lean these accidentally like so, I can get the leads to touch, and that's not good. So again, I'm not a big fan of this, even though I completely understand they save a lot of space and you can reduce the dimensions of your board by using them. I just don't, I think that they're failure prone, but I'm a little too picky about that. Most people would not care at all. Now, one thing I do want to point out on this board, if you look, say, here, R21, there's the resistor base and the lead, and next to it is their test holes for ground, for C. There's another test point D, B there, test point D there, a ground hole, test point A. Make sure when you're doing this you don't actually put one of the leads through the test points. Just be careful, but if you're going quickly, you might actually put a component lead through a test point, and then obviously things will not work out so well for you. So I've talked about the resistors, and now I've got a bunch to put in. So again, we'll go back to fast motion playback. Alright, all the resistors are on board, and I'll show you one of the things I was talking about here. I can get a good focus. Right here, these two, I was a little casual, and these two resistors didn't go straight up and down when I soldered them in. And as you'll notice, the two leads are touching. And again, that's simply because they're stand-up resistors, and they will lean into each other. If later, when I put this in a rack and I'm reaching back around, I could theoretically bump that resistor again and ground those two leads together, or short those two leads together. Again, I just don't like stand-up resistors for that reason. Next is the electrolytic cap. There's only one. Long lead goes to the negative side, positive side. Trying to see if this is the right one. Yep, 47 microfarad. And they're using a line. They're using a square pad for the positive lead and a line and a round pad for the negative, which is not the way everybody does it, but doesn't matter as long as you know. And again, this is completely different. I don't even know. Oh, the picture they're showing is for the EDU mix. Now, I don't have that one, so there is another module that I don't yet have. Okay, I'll figure that out, because the picture in the user manual for this one shows the EDU mix, not the EDU sequencer, which is kind of funny. And could cause an inexperienced builder to get confused because it doesn't match the circuit board they have in front of them. And now we'll do all the transistors. And there are 4 of them. And as always, instead of trying to fight them out of the machine feed cardboard and tape, I'll just clip them off. Less frustrating this way for me, at least. Of course, then transistor jumps across the workbench. That's why. Got sides. Okay, so and again, on their builds, they build their layout has the middle pin being bent forwards, not backwards. It's typically you go middle pin backwards, but not on these. And I'll get the power connector. Yeah, I'm back in the sequencer manual. It's still on page, in case anybody from Erica ever looks at this, on page 57, the picture for the capacitor has the EDU mix photograph, not the sequencer. Interesting, the 1 nanofarad that they show in the picture is also a film cap, but it's a ceramic disc cap in what they included in the kit. Not a big deal, but again, if you're new to this, you'd be wondering what's going on. So we've got one 2K and one 5K trimmer to put on. That's a 2K, that's actually a 2.5. So this says it's a 2K, but the part is actually a 2.5K. We're done with all the components on the component side. So before we move on to the other side, I'm going to check all the solder joints. I got to trim these too. Going to check all the solder joints, and I do that with my trusty index card so I can isolate each line and focus on them so I don't get overwhelmed by looking at all the solder points all at once. Looking for good solder flow, making sure all the points are actually soldered, because I've caught myself having missed a solder joint or two in the past. Okay, that all looks good. Now we can go back to, or we can go on to, the mechanical components. So what, different than others, they would like you to solder the jacks in after you put them on. I'm not going to do that because that's not the way I typically work. I put all the components on, then put the faceplate, faceplate on, and then solder to make sure everything is aligned properly and I don't have to fight. What I am going to do is make sure we've got the right potentiometers in the right spots, because most of these are 100K, but there is one 250 that goes there, so we want to make sure we don't get that wrong. Okay, those are all on the board. Now I'm going to put all the switches in. I'm going to take the nut off this. A little bit captured. Okay, so we've got everything through the front panel except the LEDs, and I'm not going to do those right yet. Now we'll do the pots, and as you can see, again, the leads on the pots are right up against these diodes. So you want to be very careful with that. Okay, now we'll go back and do the LEDs. So let's push them all through. They're all through. Good. Oh my gosh. Look at this. How am I going to solder in there? That's crazy. Okay, I'm going to have to solder the leg that's facing me, trim that off, and then try and get the iron in there for the other LED lead. Man. There's just no space to get in here. I'm going to actually, hold on, I'm going to turn off the cameras for a minute. I'm going to switch soldering tips. I took the bent that I usually use off and put my straight on. Hopefully I'll be able to do this better. Make sure that's clean. I haven't used it in a while. Okay, that one's good. That one's good. That one's good. That one's good. And that one's good. Now I'm going to go, before I do anything else, I'm going to just double check that they're all in, and they all are. Now I'm going to, as I said, trim those the one lead off. Okay, now let's see how successful I am getting in at this one little lead here. I think I got it. Yeah, I got it. So while these are educational kits because of the manual and so on, these are not necessarily beginner modules. If you haven't done a lot of soldering, you might be a little leery of some of this. Okay, this is silly. I cannot get my flush cutters in on that LED lead. So I'm going to have to trim it off a little higher than I normally would. That's really too bad. That's very, very tight in there, huh? Now we'll put the ICs in, the decade counter and the op amp, multiple op amp. I think in this package, I think they've got, oh, I don't know, I'd have to look. Make sure I've got the right chip in the right socket, and that's not the right one. That goes in there. That's in. Now I'm going to put all the rest of the panel nuts on. And now we'll put the power connector on. Make sure everything works. So that's it. So that's the front, side, back, other side, top, and bottom. Now we'll put it in the rack. Alright, so we're in the rack. I haven't turned anything on yet. As you can see, we've got the sequencer, the EDU VCO, the EDU envelope, and the EDU VCA. So it's all EDU units in this test rack that I've got set up. So it's powered up. And look at that. It's working already. controlling Note CV with the little MIDI keyboard and a Bufaco MIDI thing. So let's turn everything off. So the lights still trigger even though it's not sending gate out. When I turn gate on, now we'll go to 4 steps. And I'm not getting an LED on a gate 4. I may not have soldered that well enough. So let's turn on gate 5. And I'm not getting an LED on that one either. Let me take a quick look behind. Well, they seem to be soldered okay, but I'll figure that out later. I'm not too worried about an LED not working. So let's turn this back up. You can change the rate. You can change the level of out on each of those, but I'm not going to do that. So that's it. It's a very simple sequencer, doesn't do a lot, and fits with the others. So now I've just got to get the mixer. Again, I didn't know there was a mixer, so I'm going to have to find that and get that put together. So that's the little EDU sequencer from Erica Synths. Hope you enjoyed the video. I'm going to check these 2 LEDs right now. I may come back in if I can see what's wrong with them. But for now, see you in the next video.